Hi friends, today I'm going to share with you how you can avoid a collision in a HashMap data structure. As a solution, we use LinkedList. So first, we try to understand the problem, the technique proposed to solve this problem, and finally implement this solution using Java programming language. So if you are interested, stay with me. Let's begin by the problem. We want to store a pair of data, identification, description in a table with length v by avoiding the collision using a linked list. The position of the pair objects is calculated according to the summation order of identification property. For example, we have pair 1, here in identification we have ABC, and description is description of IBC. So this is the second property. So the last line shows us how you can calculate the K. K pair 1 equals order A plus order B plus order C. So 0 plus 1 plus 2 equals 3. So we want to store from pair 1 to pair 6 in a table with length V. So the K of ABC equals 3 mod 6 equals 3. So we add mod to assuming each pair within the interval 0 and V. So pair 1 in a case 3. Pair 2, so the K equals 7, 7 mod 6 equals 1. So we put pair 2 in the first row of the table. So pair 3, K equal 3 mod 6 equals 3. So as we see, this is pair 3. So here we have a collision because here first we have pair 1 and pair 3 and also pair 6. So here we propose to create a linked list in each content of the table. So pair 6 CBA, the K of CBA3 mod 6 equals 3 pair 6. So as we see here, we have 3 cases fill with the data and 3 cases are empty. Now let's try to implement this data structure using Java programming language. So we try to add element into table, delete element from the table, check if the pair exists in this table, and also we try to calculate the empty slot in the table. So let's move into Java program. So this is the project. So here I create an interface with this method, add elements, and here we have pair object, delete element is exist, pair, which return a boolean, print the hash map for printing the whole table, and get empty slot, which return an integers. So let's take a near look about the pair. It is a simple class. We have identification and description. This is the constructor, and here we have getter, and here to string print this object. So as we see here, it's like this: identification and a description. So this is the two property. Here we have service HashMap implements the HashMap. So here we try to implement this interface. So here we have two property, max value, which represents the length of the table, and here we have a table which contains a linked list of pair. So this is the constructor. I initialize max value, I create new object and assign it into table, variable table, and this is add element. So first I check if this pair exists. So we don't add the pair exists before. So if yes, so I throw exception, pair exists, this pair exists in the table. Exception extends runtime, and here I show a simple message. So let's take a near look about is exist. So this is the function. So checking from the key and the description pair if exists. So first we have key hash value pair get identification. So hash value, so this is the function hash value. So this allows me to calculate the order of each letter, so beginning from order A, and here get the ASCII code of small letter a, so this is, and here we have a loop summing the order of each letter starting with order A, which is 0, so order A 0. So after that I put this symbol mod max value, assuming each pair within the interval 0 and max value. So this is the hash value. To calculate the k, let's return into is exist. So here we calculate the k. So if table k equals null, if the k doesn't exist, say I return false. And here if the k exists, we need to check from the description. So here I check from the description. If LinkedList.get description dot equals ignore case pair dot get description. So if this yes, I return true. If the pair exists, means the k and the description. So I check from these two property, k and the description. So if yes, I return true, else I return false. So this is the function is exist. So if doesn't exist, so here I calculate the k, get k of pair using its identification. If table k equals null, so here we didn't have an object of LinkedList, so here I create an object of LinkedList. If the object of LinkedList pair doesn't exist, so I create it and I add this pair from the argument, and I assign the created linked list into table with k and dex. So here else the object of linked list exists. So the object of linked list was created before. We adjust the pair object to the list table k dot add pair. So this is add element, and here we have delete element. I check if this pair doesn't exist, I throw new exception pair not exists in the table. Else, so here I calculate the k, and here I grab the linked list and I loop over this linked list. If the description equals the description of this pair object, I remove it from the linked list. So this is the delete element. So print HashMap. So here I print just the occupied value of table. So here I print just index 0 and 1 and 3 in our case. And here get empty slots. So counting the empty slots of the table. So int count equals max value. Here loop over all the table, and if linked list different than null, I decrement the count, because here the count equals max value, and each time if the p different than null, I decrement the count, and here I return this count. So this is the service of HashMap. So here let's go into main class. So here I create a list of pair, and here we have identification and description. So as we have in this example, from ABC to CBA, from ABC to CBA, I create a list of objects. So here we have max value 6. So here I create new objects from service HashMap, and here I loop over the list pair, and in each time I add the element. So here result after adding element. So here also I print the HashMap. So let's run. So this is the output result after adding elements index 0 with pair identification def. So as we see here, pair 5 def, and this is the description. Index 1 of the table contains 2 pairs, ADE and AED. Pair 2 and 4, ADE and AED. Index 1, and here we have index 3, pair 1, 3, 6. So index 3, as we see here, we have 3 objects of pair. So this is our table. So here, result after adding elements, and here we want now to delete a pair element. So list pair dot get 2. So 0, 1, 2. I want to delete this pair ACB. So deleting a pair element, pair to delete. So here we want to delete ACB. We want to delete this. So deleting a pair element ACB and the description of ACB. After that, we got this result. So as we see here, ACB doesn't exist. First pair and second pair. And finally, we want to get the number of empty slots. So get empty slots, we have 3. So as we see here, also we have 3 empty slots. So now let's try to talk about time complexity. So time complexity to add a pair object is big L1, keeping tracking of the last cell of the linked list. The time complexity of adding, it's constant, because always we keeping track of the last cell of the linked list. Time complexity to search an object in worst cases is big Ln, the length of the whole linked list. Time complexity to delete an object in worst cases is also big Ln, length of the linked list, because we need first to find the pair object before deleting. I wish this video will be helpful for you, and we will meet in other videos.